The personal protective equipment, PPE, worn by actors in this video was selected based on a risk assessment of the chemicals used in the experiment and conditions simulated in the activity. In scenes where the presenter did not wear PPE while in the lab, all chemicals were removed to eliminate chemical hazards.
In the previous video of this series, we looked at general strategies for minimizing risks in the lab. In this video, we'll learn about some specific techniques for minimizing risk when using chemicals and lab equipment. Minimizing risk is part of a larger process called RAMP. RAMP stands for Recognize Hazards, Assess Risks, Minimize Risks, and Prepare for Emergencies. For this video, we'll assume you've already completed the first two steps of RAMP, Recognize Hazards and Assess Risks, and also viewed the previous video about strategies to minimize risk. There are a wide variety of lab techniques and behaviors that can minimize the risk of chemical exposure, personal injury, and property damage. Let's look at some examples. Messy lab spaces increase the risk of trips, spills, or using the wrong reagent during experimental procedures. Put away book bags and other items unrelated to the experiment. Also, make sure your work area is clean. You should periodically step back and examine your workspace. Put away unused glassware and equipment and avoid having containers of unneeded chemicals on the bench. To keep your workspace organized, properly dispose of chemical waste as soon as it is generated and as directed by your instructor. But make sure you don't discard chemicals you need to use later. When using a lab notebook, a computer, phone, or calculator in the lab, be sure to keep them away from chemicals that may damage or contaminate them. One way to protect calculators and phones is to put them in a plastic baggie. Now let's look at two common lab techniques and how to reduce the risks associated with them. Titrations require the use of glassware such as burettes, pipettes, beakers, or flasks. When using glassware, be sure to inspect it for star fractures or hairline cracks. Simply bumping or heating a flask or beaker with a hairline crack can cause it to break. Many solutions and solvents look just like water, so it's important to temporarily label beakers and flasks while in use. Unmarked containers can cause confusion, which could lead to you or someone else mixing the wrong chemicals. The titrant is a solution of known concentration added to the burette. Pouring from a reagent bottle can be awkward and increases the risk of a spill. It's best to pour from a small beaker over which you have more control. After estimating how much titrant is needed, pour about 10% extra into a labeled beaker. Be careful not to let drips run down the side of the reagent bottle. This can cause a minor spill and also leaves drops on the bottle that the next person might touch. Wipe off any drips and completely replace the lid. When pouring the titrant into the burette, keep the top of the burette just below eye level. This makes it easier to watch the pouring process. Be sure to pour slowly, especially if using a funnel, to make sure you don't exceed the volume of the burette. Place a large beaker under the tip of the burette to catch any spills. A pipette is often used to measure a known amount of the solution to be analyzed, also called the analyte. To safely connect the pipette to the bulb, grasp the pipette close to the end and gently insert it into the bulb. Applying too much force can break the pipette, which can result in serious injury. It's important not to place the pipette into the bottle of stock solution to avoid contamination. Obtain 10% more than you need in your beaker and pipette from the beaker. Any excess should not go back into the stock solution, again, to avoid contamination. If you have leftover titrant or analyte, you can offer to share this with a lab mate. Otherwise, dispose of it in the proper waste container. Chemical synthesis is another common lab experiment with both chemical and procedural hazards. A common process is to mix solutions of chemicals, heat and stir the mixture to produce a precipitate, and isolate the precipitate by filtration. To start a chemical synthesis, you may need to weigh your reagents. Take your reaction flask and notebook to the balance. Obtain the desired amount of each solid in small increments. If you get too much at first, put the excess into a waste container to avoid possible contamination of the original reagent. If you spill any solid at the balance, clean this up immediately and put the spilled solid into a waste container. Place the weighed solids into the flask immediately rather than trying to walk through a crowded lab with the solids on weighing paper. For reaction in water, heating is usually done on a hot plate. When using any electrical equipment, it's best to check the cord for frayed connections. Keep the cord off the hot surface and set the hot plate on a dry surface. If there's any chance a hazardous gas will be produced, conduct the reaction in a hood where the gas will be quickly removed. This includes reactions that use a flammable organic solvent too. A properly functioning hood will minimize the chance that the organic vapor comes in contact with the heat source. Hot glass looks just like cold glass, and a hot iron ring looks like a cold iron ring. Handle any hot object with beaker tongs or crucible tongs. These are not interchangeable, and using the wrong tool can lead to dropping the container, breaking it, or spilling the contents. Sometimes a hot object is best handled by special heat-resistant gloves. Hot beakers or flasks should only be placed on surfaces that are heat-resistant. Spills of any solids or liquids should be cleaned up immediately. Typically, your lab instructor will take care of this or show you how to do so. As noted earlier, at the end of an experiment, you often have leftover solids, solvents, or solutions. Share these with lab mates if possible. Somewhere in your lab, there will be a waste station that has containers for the various wastes. As noted earlier, it's very important to put each waste into a properly labeled container. Many lab mishaps have occurred from mixing incompatible chemicals, sometimes leading to explosions. Always close the waste container after adding your solution. When washing your glassware, be sure not to leave anything in the sink. Broken glassware in the sink is especially hazardous. Be sure to tell your instructor if you see this. Wipe your area with a wet paper towel or sponge and return all equipment to its proper location. If you're using a Bunsen burner, double check to make sure that the gas valve is off. If you use disposable gloves, remove them correctly and discard as directed by your instructor. And it's always a good idea to wash your hands when you're done. In this video, we covered some common techniques for minimizing risks in the lab. The key thing to remember is to be mindful of what you and others are doing in the lab at all times. And before any experiment, always think about RAMP. Recognize hazards, assess risks, minimize risks, and prepare for emergencies. To learn more about the other steps in RAMP, be sure to check out the other 5 videos in this series. You can find them by clicking here, checking out the links in the description, or visiting acs.org/safetyvideos. Remove them correctly and describe below. acs.org/videos.